Okay, what do we have here? A new day, a new streak because the medium one from yesterday was unsolved. Sad. This one I have previously solved, so hopefully I can solve it again. Find kth bit in nth bit binary string. Given two integers, positive integers at n, k, the binary string s sub n is formed as follows: s sub 1 is equal to 0, s sub I is equal to s sub I plus 1 plus the reverse of the previous string. Reverse, invert. What is invert? Oh, invert. I see. It changes zeros and ones. Okay, 0. So the next one is going to be 0, 1, and 1. Because 0 is inverted to 1 and reversed, it's still 1. So then this one is 0, 1, 1, and then 1, and then 0, 1, 1 inverted is going to be 1, 0, 0. And then reverse be 0, 0, 1. Okay, yeah, so 0, 1, 1, middle 1, 0, 0, 1. Alright. And the next one will be this thing plus a 1 plus this thing reversed inverted reverse. I guess these things, the composition of these two functions is order doesn't matter. Okay. Return the kth bit in s sub n is guaranteed that k is valid for the given n. Okay, so so kth bit k being 0 indexed, 1 indexed, no 0 no 1 indexed. K equals 1 gives you the 0, gives you the element at index at the start. N equals 3. First bit is 0. 11th bit is 1. N goes to 20. Okay. After 20 iterations, it's 42 to the power of n. I guess it more than doubles each time. 0, 3, more than doubles each time. 7, 3 to 7 is slightly above 2. Okay. So, what is the general technique for these again? What is the general technique for these? I think you need to just find the parent. Yeah, I think you need, so if you have k, you need to trace k up the iterations to where it starts at 0. So if k is, let's say, 10, you need to trace it back to like 5, 2, 1, 0, something like that. You need to be very precise about the trace though. So I think if you have a string, the first time the kth index in the string appears, for instance, the first time I'll go by zero indexing. Index 1 appears is in S2, and after it appears, it's the same value each time, right? Technically, it's always going to be the same value once it appears. But there is going to be an iteration where it first appears. So I need to find that first iteration where it appears, because that's the iteration that I kind of want to trace from. So like k equals 11, it might appear in the third iteration. Technically it doesn't. It appears in the fourth. But because at the iteration that it appears in, it first appears in, it has a lineage back to parent. Back to a certain index in the parent. So when it first appears, say this is the 11th value, it's going to trace back to previous value and previous value inverted, reversed in the first half. Okay. Okay. Let me create an array of lengths. So I think I need to know the lengths of these things. I think maybe for everything, for something in range 20, which is the maximum number of iterations, I'll go ahead and do lengths appends current, and then current is doubled plus 1. Yeah. Okay. And then I just need to iterate backwards. So let's say so if let's say how to do this? I want to go from k to the previous value of k. Like k is 11, or let's say k is even 3, right? 3 or 4, k is 4, and n is 4. Because that value of k is in the first, is within the length of the previous iteration, then it's going to be the same value from the previous iteration. But if it was not in the length of the previous iteration, like let's say it was like 6, so 6 trace back to here, but 6 doesn't trace back to second iteration because second iteration only has a 3 length. So therefore, it remaps to something inside. Unless it traces to the middle value. If it traces back to the middle value, then what? It should never trace back to the middle value. The middle value is just fixed. I see. So I think if k, so I think I need to handle the middle value especially because there shouldn't be anything tracing to middle value. So let's go ahead and print this. This is really pre-computed. Pre-compute lengths of each iteration string. So length is going to be this. And then check if the this is the trivial case. If k is middle index of string, return 1. So if let's see, n divided by 2 plus 1 equals k. Is that how I define it? So if it's 3, the middle one has to be 1. Maybe it's just k times 2 plus 1 equals n equals length of string. If 2 times k plus 1 equals length at iteration, I think maybe n minus 1, turn 1. So if k is, this is using 0 indexing. I think it might be 2k minus 1. Or this needs to use 1 indexing. So let's say k is 1, 2, 3, 4. N is 3. So it should be 2 times 4 minus 1 is 7. 7 is n is 3, so n minus 1 is 2, 0, 1, 2. Yeah, okay, I think that works. And then I just need to do the correct logic. So I need to iterate backwards until I reach n equals 1. Or n equals 1, which case I know it's going to be exactly 0. So I think I need to do something like flips. Where flips is the number of times it needs to invert itself. And if it inverts itself an even number of times, then the answer is going to be 0. And if it inverts itself once, then the answer should be 1. Because 0 inverted an even number of times, it's going to be 0. Okay, so for, I guess it should be while n is greater than 0. And go backwards in iterations. I might. It's always going to be used n minus 1. I wonder if I should just use n minus 1. Easier to work with 0 indexing. So this is s sub 0 rather than s sub 1. So while n is greater than 0, then if Really, I should probably do this for both k and n. Yeah. Okay, so let's go change this logic. It's going to be 2k plus 1 and length at 0 at length at n. Okay. So while n is greater than 0, you go backwards. So what happens here, if it's in the later half, then it needs to invert. If it's in the first half, it needs to stay. Okay. If k is greater than lengths of n divided by 2, something something, and then n decreases. I guess I can just use a for loop then. Index in range n down to 0. So then this is just going to be length index. So if it's in the first half, it stays because it's going to be the same in the previous iteration and previous string iteration. And if it's in the latter half, I need to figure out the proper thing. And I need to invert, right? It has to be flipped. Flip to whatever's there. Has to flip. And I just need to find the correct index. I think the correct index would be how far away it is from the last. K equals length of this index minus k, because if it's at the very end, then it goes back to 0. Just minus k minus 1. Length minus 1 minus k. And then I go ahead and say, after all this is done, if flips is odd, I guess return 0. If flips is an even number, else return 1. Whoops. Flips, flip, flip. Flippity doo dah day. That needs to be strings. Okay, good, 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 good. Oh, so close, so close, so close. Trivial case failed. Interesting. N equals 1, K equals 1. Why would this even... Oh, this hit my trivial thing. This hit my trivial case, yeah. Trivial case is giving me the wrong thing. Yeah, so the middle one at the very first iteration is actually 0, right? So there's going to be 2 trivial case, or 2 special case. Because technically that's kind of like your middle value in that one. But it's actually 0, so it doesn't actually work with this. Looks like I just hard-coded a solution for... Yeah, whoops. Probably should do this after I change my thingamajigger, like I intended. Alrighty, sure. Everyone, or not everyone, huh? Some really slow stuff out there. I assume this stuff is creating the strings, yeah. Any case. Alright. Cool, 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 cool. Got a new streak. Anyways, summary. So, based on logic, each the kth index of the nth iteration string can be traced back to a certain index in each prior iteration. That index depends on if k is within the first half of the current iteration, it'll be at the same index in the prior string iteration, because like, yeah, prior string will have the exact copy in the next, in all future strings. If k is within the second half, it'll be mapped to something in the first half, but flipped. Also, if it's middle, then special case, it's always 1. No, it's always 1, no prior index. It's kind of prior parent index. So keep track of the number of flips, since it always traces back to 0. The number of flips determines the value at k for the nth iteration. Odd flips equals 1, even number of flips equals 0, right? If you have a 0 starting, you flip it twice, it's going to go back to 0. If you flip an odd number time, it's going to go to 1. Code works through that logic. So start by defining how long each string should be. That you can pre-compute that. Hit your edge cases. Edge case being n equals 0, n equals 1, whatever you want to define it. And a being the middle index of the nth string. And then otherwise keep track of your flips. Iterate through each index, each string iteration index. Determine if k is within the first half of the length of that string. If it is, then it's not going to flip it. If it isn't, if it's big in the second half, in which case it's bigger than the middle index, then it flips, and it also maps to something in the first half equal to the length, equal to the distance that is from the end. If you're second to last of your string and in the second half, then you're going to be second to start in the previous string. Flipped, obviously. And then just return 0, 1 based on the number of flips. Time complexity, this can be O of n, where n is the length, is that right? No, that's not right. What is this? No, I guess it is O of n, right? O of n, where n is the number of iterations, is the iteration input, since we use a loop to iterate backwards, constant with each time, each loop. Yeah, and then space complexity O of n to pre-compute the lengths of each iteration, pre-compute or store the array of pre-computed lengths of each iteration. Yeah.